Another way to minimise battery consumption and maximise range is by opting for a heat pump. The standard ventilation system in the Enyaq iV is pretty much the same as what you'd find in our internal combustion models. All the air vents are where you'd expect to find them, including the ones for passengers in the back and under the front seats. Your Enyaq iV is heated electrically by a high voltage electric element with an output of up to 6 kilowatts, but it usually operates at a lower level than this. The car already regulates the electricity used for heating to minimise energy consumption, but there's an additional option new to electric vehicles and available as an option on the Enyaq iV, the heat pump. One major difference between electric vehicles and internal combustion cars is that petrol and diesel generate a lot of waste heat. When it's cold and you turn the heater on in internal combustion cars, that same heat is used to warm the interior. However, electric motors are incredibly efficient compared to internal combustion engines and generate barely any waste heat. So, when it's cold, the heater is powered by the same source as the rest of the car, the battery, and this has a detrimental impact on range. This is where the heat pump comes in. Adding it as an option means you can keep the interior toasty warm without placing so much demand on the battery. And don't be fooled by the name. As well as heat, there's a cooling function as well, which can be combined. The heat pump reduces the load on battery capacity, increasing the range by drawing on waste heat from the traction battery and certain high voltage components. At maximum capacity, the heat pump has an output of approximately 3.9 kilowatts, but usually operates at a lower level. How does it work? I packed in science at GCSE, so I will keep this as simple as possible. Essentially, it's a little bit like a fridge, but in reverse. First, naturally heated antifreeze gets channeled into the heat pump evaporator, where the heat is transferred to the coolant circulating inside the unit. The evaporator, as its name suggests, then makes the coolant evaporate, turning it into gas. This gas is then sucked into the compressor, and thanks to the physical principle of compression, where temperature increases as pressure rises, the coolant temperature goes up to about 80 degrees centigrade. Next, this heated coolant flows into the condenser, transferring its heat into a water reservoir, storing the heat in the same way as a central heating system would. Meanwhile, the gaseous coolant becomes liquid again and flows from the condenser through the expansion valve, where it cools rapidly back to the evaporator, where the whole cycle begins again. This cycle is repeated so that heat is pumped into the interior of the car. Hence the name, heat pump. Simple.